So guys, let's implement this topology that you can see on the screen. We will going to implement layer 2 routing first. So you can see that in this topology, we have VLAN 10 and we have VLAN 20, right? So I will going to implement the VLAN 10 topology, that is the topology on the left hand side, and the topology on the right hand side is exactly the mirror image of the topology of the left hand side. So it will be your homework to implement VLAN 20. So what I will do, I will going to take an L2 switch, and to this L2 switch I will going to connect the two hosts H1 and H2 on two interface of the L2 switch. Alright, and I will going to configure the IP addresses. As you can see, the end result is that I should be able to ping H2 from H1 and I should be able to bring H1 from H2. This will be pure L2 routing because the only device that is responsible to send the packets from one host to another is the layer 2 switch that you can see in the middle. The router that you can see here is out of the context here. We will use this router when we will going to implement L3 routing. Currently we will restrict our discussion only to L2 routing, that is how a host can ping another host within the same subnet. Here the subnet is VLAN 10 and another subnet is VLAN 20. So host, that is the same host within the same subnet, can communicate with each other due to L2 routing. Alright, to make the host communicate across VLANs, we would need L3 routing. So that's the topic of discussion that we will going to discuss later when we will be implementing L3 routing. Alright, so the end result of this lab is that H1 should be able to ping H2, H2 should be able to ping H1, and H4 should be able to ping H3, but H3 and H3 should be able to ping H4, but you cannot ping from H1 to H4. That is, no two hosts in different VLANs can communicate with each other. Alright, for that we need L3 routing. So going forward, I will going to deploy only host H1, host H2 and layer 2 switch S5. Alright, and it will be your homework to deploy host H4 and H3. Alright, so let's go back to the lab. So guys, what I need is that I need a layer 2 switch. So to begin with, you can see that this IOS VL2, this is the Cisco layer 2 switch which you can use. So I will simply drag it and put it here. This is my layer 2 switch. Can I increase the size of this L2 switch? Is it possible? I think you can zoom the entire topology, but you cannot increase the size of this layer 2 switch. Anyways, now I will check how many interfaces this L2 switch has. So it has Ethernet 0x0, 0x1, 0x2 and 0x3. So it has 4 interfaces. Let me add 4 another interfaces. So the total, it has 8 interfaces now. Now I have to add host H1 and host H2. Now which device should I pick up in order to represent as host? Let's say ideally you should pick up Alpine Linux, that is this device, because it is Linux or Windows host machines which usually acts as an AND host in the real world topology. Alright, but instead of going with Alpine Linux, I will take a Cisco CSR router. So since it is a router, I will not going to use any of its routing capabilities. I will simply going to use it as an AND host. The reason is that if you reboot the Cisco devices, they can recover and comes back with the same configuration they had before. Alpine Linux do not have this capability, so every time I reboot the device, I don't want to do the configuration again and again. Otherwise, you can choose Alpine Linux as an AND host as well. So these are my 2 AND hosts. Can I rename it? Okay, this lab has very few configuration options, so we cannot rename the devices as per our wish. So let me rename this lab as L2 switching. Alright, now let me connect the links, and you can see that the two links have been connected. So that's all. We have the very simple topology. It's up to you to connect two more devices on the right hand side and place them in VLAN 20. Now I will going to place these two AND hosts in VLAN 10. So the construction of our topology is complete. Now let me start the devices. So let me wait for a few minutes to let the devices start. Let me go to the console of our switch, and you can see it is still booting up. So let it boot up. Let's wait. You can rename these devices as follows. This is my host H1. This is my host H2. So we will going to configure the IP addresses as per this slide. So here the IP address is 10.0.10.1/24 and it is 10.0.10.2/24, and it is connected to the Ethernet 0 and Ethernet 1 of the L2 switch. So name of these links can vary, that doesn't matter. So let's go to the L2 switch and see what's going on. Okay, I will go to the configuration terminal. Let me rename as L2 switch. Now I have to create VLAN 10. VLAN 10 is created. Do no shut on this VLAN 10. So VLAN 10 is created on L2 switch. Now you have to put the port gig 0/0 in VLAN 10 and gig 0/1 in VLAN 10. So for that, I will go to the configure mode again. Go to the port 0/0. Say switch port. Say switch port mode access. Say switch port access VLAN 10. Using this configuration, you have added gigabit 0/0 interface in VLAN 10. Similarly, I will do the same thing for the other port. So come out, go to the terminal mode again, interface gigabit Ethernet 0/1. So remember, I am doing the configuration of an L2 switch. No shut, switch port mode access, switch port access VLAN 10, and we are done. Alright, now coming to the AND host, we have to configure the IP addresses. So now I'm on the AND host H1. Let me configure it as H1. I will go to its interface gigabit Ethernet 1. No shut. Configure IP addresses as per the slide. It is 10.0.10.1/24. Now /24, you have to represent /24 in A.B.C.D format, and we are done. Similarly, I will go to the host H2 console, enable conft hostname H2. I will go to interface gig 1, no shut, not switch port but IP address, and the IP address is 10.0.10.2 and mask. Right, if you want to see the configuration, you can see the configuration on an interface. Show running config interface gigabit Ethernet 1. It will show you the configuration, that is the IP address that you have configured. Other configuration you can ignore. Now you can copy the configuration of the device using the command copy rs. If it doesn't work, then type out the full command copy running config to startup config. This This copying the configuration from running to start means if you reboot this device, then the device will come up with the same configuration as you have configured now. Then the next thing you need to do is write memory. Write memory means that if you can shut down this lab, you can come back tomorrow, and when you run the lab again, then the device will come with the same configuration. Similarly, I will go to the host H1 and I will do copy running to startup. Write memory. Sorry. You just have to press enter here when it asks you the destination file name, and you are done. And the same thing you can do on the switch also. I leave it to you. Now from host H1, can you ping the host H2? What is H2's IP address? 10.0.10.2. So you can see that the packets are being transmitted. Out of 5 packets, 4 packets have been successfully transmitted to the host H2 from host H1. Now in the first ping, it's always that 80% or 60% success rate is 80 or 60%, but in subsequent ping it will be always 100%. Similarly, from device H2 you can ping the device H1, right? You can see the ARP table on the device H2. So this is the ARP table. Similarly, on the device H1 you can check the ARP table, so it is learning ARP. And on the switch, can you check the MAC table, address table, and it is doing the MAC learning also. Alright, so this is the MAC address table of the Alto switch. Now coming to the packet capture, let's say on this link I want to do the packet capture. So you click this link, go to the packet capture tab. Now here the packet will be appearing if any packet is transmitted on this link. So let me start the capture by clicking the start button. Now let me do something so that packet travels on this link. So from the host H1, let me ping the host H2, as simple as that. Now let me see what is the state of the packet capture. Packet capture tool is not working very nicely. As soon as the page loads, the packet capture output gets erased. Okay, so once you are here and once the packet capture is completed, you can download the packet capture file. And once the file is downloaded, you can open this file in the Wireshark. So Wireshark is another tool that you should install on your system. So Wireshark is a tool which is used to decode the packets and see what is there actually inside the packet. So you can see that these are the ICMP ping which traverse the link on which we are capturing the packet. If you double click it, it will show you what are the various headers, what are the various fields in those headers, and you can just expand these headers and see the actual content of each packet. Alright, so you can see that this protocol value is ICMP. It means it was ICMP packet, and it was ICMP request packet. Alright, and then you can see that in this ICMP request packet, the source address was 10.0.10.1, which is the address of the host H1, and the destination address is 10.0.10.2, which is the address of the host H2. Alright, so I leave it to you to explore more, and you can go through this packet headers and understand what are the meaning of various fields here. At least you should be aware the fields which are there in the Ethernet header, because so far we have covered only the layer 2 routing, and as long as layer 2 routing is concerned, you should focus on the Ethernet header, because layer 2 routing is done by the layer 2 switch, and layer 2 switch does the switching using the destination MAC address. So you can see here, this is the destination MAC address. So this is it. We are done with this lab.